Ever wondered how you can stream a movie from another room or message a friend across the globe in seconds? That's computer networking in action. A computer network is simply two or more computers connected to share information. Think of it as a digital neighborhood where devices communicate and share resources. Without networks, each computer would be isolated, unable to connect with others. Networks let us communicate instantly, emails, video calls, and chats, shrinking distances and connecting the world. They also allow us to share resources like printers and files, making collaboration easy and efficient. And of course, the internet is the ultimate network, a global web connecting billions of devices. All of this is possible because computers can talk to each other, forming the backbone of our digital lives. To build a network, you need hardware, the physical parts you can touch. Hardware includes everything from the computer itself to the cables, switches, and routers that connect devices together. These components are the backbone of any network, providing the essential infrastructure that allows information to flow from one place to another. The Network Interface Card, or NIC, is your computer's gateway to the network, sending and receiving data. Without a NIC, your device wouldn't be able to communicate with other computers or access the internet. It acts as a translator, converting data from your computer into signals that can travel across the network. Data travels through cables like Ethernet, which provide fast and reliable connections, or wirelessly via Wi-Fi, which offers flexibility and convenience. These connections link computers, printers, smartphones, and other devices, allowing them to share information and resources seamlessly. Switches act as traffic controllers, directing data to the right device within a local network. They ensure that information gets to its intended destination quickly and efficiently, preventing data collisions and keeping the network running smoothly. Routers connect different networks, like your home to the internet, finding the best path for your data. They manage traffic between your local network and the wider world, making sure your emails, videos, and web pages reach you from anywhere on the globe. Your home router is the bridge between your private network and the vast internet. It keeps your information secure while allowing you to access online services, stream content, and stay connected with friends and family. Each device, cable, and signal plays a role in moving information from one place to another. Even the smallest component, like a connector or a cable, is vital for keeping the network running smoothly and efficiently. Without these components, your devices couldn't communicate or access the web. A single missing cable or malfunctioning device can disrupt the entire network, showing just how important each part is to the whole system. Hardware forms the foundation, but software makes the network smart and usable. Software manages connections, secures data, and allows you to control how your network operates, making it possible to share files, print documents, and communicate in real time. Together, hardware and software create the connected world we rely on every day. From streaming movies to working remotely, every online experience depends on this powerful partnership, shaping the way we live, work, and connect with each other. Have you ever wondered what really happens when you send a message or load a website from your computer? It might seem like magic, but there's a fascinating process happening behind the scenes every single time you go online. Let's break down this journey, step by step, to see how your message travels across the world in the blink of an eye. When you type a web address into your browser and hit enter, your computer gets to work immediately. The browser creates a request, essentially a bundle of data, ready to be sent out into the digital world. Your operating system then takes this data and breaks it into smaller pieces called packets. Each packet is carefully labeled with both the destination address, where it needs to go, and your own address, so the response can find its way back. These packets leave your computer through the Network Interface Card, or NIC, and travel to a switch, which acts like a traffic director, making sure each packet goes to the right place. From there, they reach your home router, the gateway to the wider world. The router examines each packet's destination and sends it out onto the internet. Along the way, your packets may pass through dozens of routers, bouncing from city to city and even across continents, all in a matter of moments. Eventually, the packets arrive at the website's server, often located in a massive data center. Here, the server reassembles the packets, reads your request, and prepares the information you asked for. The server then sends the requested data back to you, breaking it into packets once again. These packets retrace the same complex path, hopping through routers and switches until they reach your computer. Amazingly, this entire process, from your first click to the website loading, happens in just milliseconds. It's so fast, you barely notice any delay at all. Every click, message, or video stream you enjoy relies on this invisible journey, connecting you instantly to people and information around the globe. Networking transforms simple actions into global connections, making our world more accessible and interconnected than ever before. Every device on a network needs a unique address, just like every house needs a number. Imagine trying to send a letter without a house number or street name. It would never reach its destination. In the digital world, these addresses make sure information gets to the right place, whether it's a message, a file, or a video call. The MAC address is a permanent, unique identifier built into your device's NIC, used for local communication. Think of it as your device's fingerprint, assigned at the factory and nearly impossible to change. It's how your computer, printer, or phone is recognized on your local network, like a name tag at a party. Switches use MAC addresses to deliver data within your home or office network. When you send a file to your printer, the switch checks the MAC address to make sure the data goes to the right device, not just any device connected to the network. For communication beyond your local network, devices use IP addresses, logical changeable numbers that guide data across the internet. Unlike MAC addresses, IP addresses can change depending on where you connect, like moving to a new house and getting a new address. IP addresses look like four numbers separated by dots, such as 192.168.1.101. Each part helps identify your device's location on the network, making sure data travels the right route when your computer wants to reach another device. It uses both addresses, MAC for local delivery, IP for global travel. The MAC address ensures the data gets to the right device nearby, while the IP address helps it navigate the vast web of the internet. For example, a ping test finds a device's MAC address using its IP, then sends data directly. This process is like looking up a friend's name in a directory to find their exact apartment number before knocking on their door. This teamwork ensures data finds the right device, whether it's next door or across the world. Without this coordination, your emails, video calls, and downloads would get lost in the digital maze. MAC and IP addresses are the backbone of network communication. They work together to keep everything running smoothly, making sure your information is delivered quickly and securely. They keep data organized, accurate, and on the right path. Without these addresses, your network would be a confusing mess, with data wandering aimlessly and never reaching its destination. Without them, networks would be chaos. So next time you connect to Wi-Fi or send a file, remember the invisible teamwork of MAC and IP addresses, making it all possible. Networks come in all sizes, each serving a different purpose. A LAN, or local area network, connects devices in a small area, like your home or office. MANs, or metropolitan area networks, link multiple LANs across a city or campus. WANs, or wide area networks, connect networks over vast distances, even continents. The internet is the largest WAN. You rarely own WAN infrastructure, instead you lease it from telecom companies. An internetwork is simply a network of networks, connected by routers. Your home LAN, connecting to your ISP's WAN, is a small internetwork. The internet is the ultimate example. These layers let any device talk to any other, anywhere in the world. That's how your messages travel from your room to the global stage. Data is broken into packets, small, manageable pieces that travel independently. Packet switching lets many conversations share the same network, keeping things efficient. Each packet has a header with source and destination IP addresses, guiding it to the right place. Before traveling over cables, packets are wrapped in frames which include MAC addresses for local delivery. This process, called encapsulation, ensures data has the right address for each step. Routers and switches unwrap and rewrap packets as they move through the network. It's like sending a letter inside an envelope, then putting that envelope in a shipping box. Encapsulation keeps data organized and secure on its journey. That's how your information travels safely from sender to receiver. For computers to communicate, they follow strict rules called protocols. The most important suite is TCP by IP, which powers the internet. TCP ensures reliable, ordered delivery, perfect for downloads and web pages. UDP is faster but less reliable, ideal for streaming and gaming where speed matters more than perfection. Application protocols like HTTP, DNS, DHCP, and SMTP handle specific tasks: web browsing, translating names, assigning addresses, and sending emails. Each protocol has a job, and together they make the internet work smoothly. Without protocols, devices couldn't understand each other, no matter how well connected. Protocols are the shared language of networking. They keep data flowing, accurate, and accessible. That's what makes global communication possible. When your device joins a network, it needs 4 key pieces of information: IP address, subnet mask default gateway, and DNS server. The IP address is its unique ID. The subnet mask defines what's local or remote. The default gateway is the router that connects you to other networks, including the internet. DNS servers translate website names into IP addresses your computer can use. You can set these manually, static, or get them automatically, dynamic, using DHCP. DHCP makes connecting to new networks effortless. Your device gets all the info it needs instantly. This setup lets your device communicate, browse, and share without hassle. Network configuration is the foundation of connectivity. It's what gets you online every time. To organize networking's complexity, scientists use models like the OSI model, which breaks communication into 7 layers. Each layer, from physical cables to application software, has a specific job, making design and troubleshooting easier. Networks can be peer-to-peer, where devices share equally, or client-server, where dedicated servers provide services to clients. Client-server is more secure and scalable, powering most of the internet. Networking enables everything from simple messages to global business. It's the invisible force connecting our world, making instant communication and endless information possible. Understanding networking is like learning the grammar of the digital age. It reveals the science behind the technology we use daily. The world is more connected than ever, thanks to the elegant principles of networking. It's not magic, it's just really cool science.